Hi there guys, this video we're going to go through the derivatives of exponential functions. This next couple of videos will cover the calculus of exponential and logarithmic functions. So we're going to start in this one with exponential functions. The next video we'll talk about logarithmic functions. So this is on your handout, so page 49 shows the derivatives from first principles definition of how we get the derivative of an exponential function. F of x equals a to the power of x, this thing here. So you don't have to know this, but it's an interesting one to look through as to how we use differentiation from first principles. You'll see the final result down there. But we're heading for a function that is its own derivative, which is an interesting thing. And we know that that function is y equals e to the x. So the derivative of e to the x is e to the x. So we talked about that, and we said that the gradient of the curve at any point is the same as the y value of the curve. So that's an interesting property of this special number e. So we want to extend that now to look at what's the derivative of e to the power of f of x. So using the chain rule, and then with the product rule and the quotient rule. So I'm just going to show you a few examples here. So if we look at these examples on here, e to the minus x, e to the 2x plus 3, and e to the minus x squared are all of this form e to the fx. Now if we use the chain rule, what we have to remember is when we were dealing with things like, let's say 2x plus 1 to the power of 10, we just said, okay, let's treat that 2x plus 1 just like it's an x. So we do that, which is the normal rule for differentiation, but then we have to multiply by, and that's the thing to remember, multiply by the derivative of the thing inside the brackets. We're going to do something really similar for functions of the form e to the f of x. We're just going to treat it like it's e to the x and then multiply by the derivative of the power, basically. So that is that rule right there in the bottom line. We have e to the f of x, the derivative is just e to the f of x, and the chain rule tells us we have to multiply by the derivative. So that's the important thing here when we're using the chain rule. So if we have something like 2e to the x plus e to the minus 3x, let's look at this first one here. So the derivative of 2e to the x is just going to be 2e to the x, that doesn't change. The derivative of e to the minus 3x is e to the minus 3x, but then we have to multiply by the derivative of negative 3x, which is negative 3. So we get this thing here. This is all on page 52 of your handout. The derivative of x squared e to the minus x. Now we're going to use the product rule. So if I just do b in a little bit more detail, I'm going to say u is x squared, and I'm going to say v is e to the minus x. So u dash 2x, v dash. Now, the derivative of e to the minus x is going to be e to the minus x, so we always just write down whatever the question is, times by negative 1. The derivative of negative x is negative 1, so we could write v as negative e to the minus x. Okay, let's just add a page in below here. So doing the usual thing that we do, the derivative of that whole thing there, u dash v plus v dash u, I'm using the product rule, so 2x u dash times v e to the minus x plus v dash negative e to the minus x times by u, which is x squared. Now you'll notice that there's some common factors there, and we can tidy that step up. Obviously x is a common factor here, and e to the minus x is a common factor in both of those terms. So that will leave us 2 minus x, and just check that's right, 2x e to the minus x, correct, minus x squared e to the minus x, correct. Okay, again, writing in that form is really handy because the question may be then, what are the stationary points of that function? You can see that when is this equal to 0? It's going to be equal to 0 when x is equal to 0 right there. This value of x will never help us to find when it's 0, and also when x is equal to 2. So the stationary values there would be x equals 0 and 2. But we won't go any further than that. We're just concerned at this stage with using the quotient rule, chain rule, and the product rule. rule correctly. Okay, let's do C, which is using the quotient rule, and this one is e to the 2x over x. Okay, and I know you got the answer there, I'm just going through it. So u is e to the 2x, and v is equal to x. So u dash, here again we're going to use the chain rule, is 2 e to the 2x. Again, just the derivative, write down the original question times by the derivative of 2x. And v dash is 1. So the derivative of the whole thing, dy dx, is u dash v minus v dash u divided by v squared. That's the formula for the quotient rule that we covered before. Top line, we've got a common factor of e to the 2x. So that will give us 2x minus 1 divided by x squared. That's the simplest we can write that. And again, the derivative of this curve is 0 when, never for that value of x, and for that one there when x equals a half, we've got a stationary value. At x equals 0, we've got a problem. We've probably got an asymptote. The derivative is not defined at x equals 0. If we go back to the original curve, you can see when x equals 0, we're going to have an asymptote. The curve's not defined there. So there's a quick example of using the chain rule, the product rule, and the quotient rule. Let's look at a few more examples that are a little bit tougher. Okay, let's look at this one. E to the x times 1 minus x squared to the power of 3. This is the product rule that we're going to be using here. So we're going to say u is e to the x and v is 1 minus x squared cubed. So here we're going to need the chain rule to differentiate v. U is easy. It's v that's a little bit tricky. So we're kind of defining the chain rule over here and doing the long version. I think over here you could go straight to going 3 1 minus x squared times negative 2x. And when you do that, you'll get your answer there, negative 6x 1 minus x squared. Okay, so we're using the product rule. So the derivative is u dash v plus v dash u. There's our answer. Careful with the, just that's plus and a minus, which means that whole thing is negative. And now look at our common factors here. E to the x is common to both terms. X is not common, but 1 minus x squared is common to both terms. So that is a bit tricky. What do we have to times this by? To get this whole thing, we need to multiply by 1 minus x squared. What do we have to multiply this by to get the last term? We have to times by 6x. So there we go, there's our final answer. 1 minus x squared minus 6x. Again, to find when this is equal to 0, never for that x, plus or minus 1 for this one, and this is a quadratic that we could possibly solve to find the other values of x where they're equal to 0. So there's a few examples of differentiating e to the x using chain rule, product rule, and the quotient rule.